All right, hello, folks. So today is our last lecture of the semester. We do have the finals time that is on Thursday, so I'll talk about that a little bit at the end as well. But yeah, this is basically it. So I'm going to talk about the sort of more tile map stuff. Potentially, some of this could have been useful for sort of working on stuff over the weekend. Particularly if you used any tile map stuff and you had 100 tiles you're trying to deal with, and sort of painting a map was a real pain. I'm going to show you a much easier way to do it. There's a little bit of pain at the beginning, and then painting a map becomes super easy. So some of this stuff may have been useful. It's just we didn't quite have time to throw it in. Before that, I want to show a couple of things that's really didn't fit anywhere else. Uh, One of these specifically is about raycasting, so I want to do a little bit of raycast stuff here at the beginning. We're just going to use the same project that we've been doing the tile map stuff on, so there's no need to create a new project and do all that stuff. But I did put another script. The script itself just contains, it's this follow mouse script here. It just contains only the code that we use for the weapon inspector, where it just follows your mouse. It rotates towards your mouse. So it's not code that you haven't seen before. It's code that we've already written. It has the arctangent and dealing with the quaternion and setting the rotation, stuff like that. So we are going to use that, but we're going to add some of the raycast stuff to it, and you'll sort of see why as we go through why I sort of wanted to use this script. So just so we don't have to dig through another project and copy and paste out the code or something, I just provided you with this follow mouse script. We'll talk about the final exam schedule probably at the end, and then I'm on this GitHub page. It says 2D Extras one, and we're going to talk about this a little bit when we get to the tile map stuff today. There was a notice that they just added. Literally, it was 8 days ago. If you look at the change of the README. So this is one of these things about Unity sort of constantly changing. So I'll point this out as well. But the way that I have this written up in the lecture slides was from 6 months or a year ago, where this was the only way to do. Grabbing this repo was the only way to do certain things. So from the notice, it looks like they're going to add this stuff into the package manager, which I never really understood why they didn't already do that. But it looks like they are going to be doing that in the near future. So again, this is one of those things that 8 days ago they finally say, "Hey, we're going to add this into the package manager," rather than sort of keep it separate on a separate GitHub page. So I'll talk about that here in just a little bit. But like I said, first I want to grab this follow mouse script, and I actually already have it loaded in. But I'm just going to use the same project for the tile map stuff. I just created a new scene. You don't necessarily have to create a new scene. I just wanted it to be empty for us, but it just has the main camera and a directional light. So it's just brand new scene. We're going to throw a couple of graphics in here. I'm probably going to use the chest graphic and a barrel graphic, and attach this follow mouse to one of them. The main demonstration that this is going to be is these raycast, and we're only going to do a 2D raycast, but 3D raycasts work the same way. It's just you use basically vector 3s to do stuff rather than vector 2s. So in this empty scene, in that same tile map lecture project, I'm going to add in the chest graphic. So if I look at my sprites here, I have my chest. I can just drag one of those in. Right now it's black because it has the sprite lit default. So I'm going to change that to the sprite unlit default. So I'm going to make sure the material is correct for this. If you need to make a new material, you can do that as well. There's a material I think in here that is the sprite lit default, and you can change the shader on that. It doesn't really matter if you can view it correctly or not. We're just going to be spinning it around. So my follow mouse file here is just that code that follows the mouse. There is an extra variable up here, this ray color. We're going to actually draw the raycast. So I just left that in there. It's something that the ray color is going to be red most of the time, but if it hits something, we'll change the color to green. But the point is, in update, it's just going to be rotating around. So I'm going to add that script to this chest that I put here. And when I run play, it should follow my mouse around. So that's all that I really care about this doing. So the actual graphic doesn't matter. So if it's black because you're using the lit sprite, it doesn't matter. I'm also going to add in one more sprite. I'm going to add in the barrel, and I'm just going to throw it up here. And I'm going to change it to the unlit. So I have the barrel up here. One more piece to this is a collider. So I'm just going to add a box collider. And let's actually make it, rather than the box collider, the 3D version, let's make it the box collider 2D. So with the gizmos on and the barrel selected, this is, here, that's my collider. So we can see the collider. It's fine. It's reasonable. For the demonstration, it doesn't matter. You could use a circle collider. You could use a capsule or any of the 2D ones. You could use it. It would be fine. So if we run now, I just have this guy rotating around. I can see the collider here because I have gizmos turned on. Actually, let me grab the pen tension thing here. It's a little bit easier to see. Move some windows around. There we go. Okay. So up here, I have gizmos selected. So I'm in the game view. I have gizmos on. If I turn gizmos off, then it'll look like it would sort of look in the actual gameplay. But I want gizmos on because I do actually want to see this collider because we're going to mess around with it. So when I play, I have this chest that rotates, and I have a barrel with a collider on it. So there's sort of nothing here that we haven't done before. There's no variables for me to change in the follow mouse script, but we're going to be adding to this follow mouse script. So whether you created a new scene or whether you just added this stuff in on top of the other sort of tile map stuff that we had in the starter scene, that's perfectly fine. You just need a graphic that rotates around, and we need another graphic that has a collider on it that just sits there. So in our script, this is the sort of orient stuff. We're not going to change that, but we're going to do some raycast stuff. When you do a raycast, they typically come from the physics system. It's just going to start a ray at a particular point. You decide where the ray starts, and it shoots the ray out typically some distance. And it'll record anything that it hits. From sort of a first-person shooter perspective, if you've sort of heard of certain weapons, like a lot of times like sniper rifles and stuff, tend to be like hit scan weapons. If you've heard that term before, hit scan, it's basically a raycast. The raycast happens instantly on the frame it happens, and it records if there was a hit. So there's no sort of travel time. So if you're coding up a game and you don't want travel time, a raycast to determine a hit, you'll still play graphics and sounds and all that kind of stuff, or some sort of animation when you fire a weapon. But if you want to determine if there's a hit in that instant where you fire, then a raycast is what you want to do. So we're going to do a 2D raycast, but of course, there's 3D versions of all of this stuff. So the first thing we do is we do this physics dot. So physics is the, and actually we need the 2D version, we need physics 2D. This is a class, so the actual raycast itself is a static method. So you call it with the class name. And then we can do a raycast. There are lots of overloads on this. So this is something that you can look up if you need a different type of overload. Typically, you're going to have an origin and a direction. Those are going to be sort of the two sort of main things that you need. The rest of the arguments are typically related to how far do you want the raycast to go. Maybe you don't want it to go sort of an infinite amount or a large amount. Maybe you want a short raycast. Things like layer masks, maybe you want it to ignore certain colliders and only hit different types of colliders, or only hit triggers, for example, rather than actual colliders that aren't triggers. So there's other options for what the raycast will record, but typically you will need an origin and a direction. So origin is just going to be this dot transform dot position. So it's going to be the chest that follow mouse is attached to. The origin is going to be the position of that chest. So wherever the pivot point is, 0, 0, 0 in the game world. Then we need a direction. Before I put this in, I'm going to create I think I'm going to make it a vector 3. It doesn't really matter if it's a vector 3 or vector 2. I'm just going to make it a vector 3, and then we'll put it in here, and it'll convert it automatically. And I'm going to call this up. You'll see why I call it up here in just a second. And this is going to just be a vector 3 dot up times some distance. So let's say I want to do a raycast 10 units. And these are unity units, so there's 10 unity units. I'm going to put up here. That's my direction. If you put a third argument, there's a float for distance. Now you might think, all right, well, I already put distance in here, so do I need distance here? Yes. And the reason I put a times 10 here for a distance is for actually drawing the raycast later. So you do need a distance. So this is literally just the position. The direction, think of it as like it'll automatically normalize the vector for you. So you get a direction vector. And then I'll put 10f here. And actually, I'm going to create a float. I'm going to call this the cast distance. And we'll set that to 10. And then I'll just use that variable instead. And that's almost it. That's it. I literally just did a raycast. And that'll happen every frame. So every frame, there's a raycast that goes out. It goes out 10 unity units in this direction up from the center or the pivot point of my sprite. If we run this, we're not going to see anything at all. At least we're not going to notice that anything here is doing anything, that anything here is working. We run and we spin around and yeah, whatever. Right? You can't tell that anything's happening. The physics 2D works slightly differently for a 2D raycast than for a 3D raycast. The 3D raycast returns only a true or false value. To get information about what it hit, you actually use one of the arguments. The 2D raycast, though, actually returns, and if I hover over this here, you see that it returns a raycast hit 2D. So I'm going to have it catch one of those. A raycast hit 2D. Raycast hit 2D, and I'm going to call it hit. So if it hits anything, if it hits a collider, it's going to give me back some info about that collider. So I can do something like this. I can say if hit.collider is not equal to null. So in other words, it did hit something. Then I can do whatever I need to do. So maybe I want to print hit. Remember, I'm doing this every single frame. So I'm going to launch out this raycast, check and see if the collider that it hit is not null. So hit always comes back as an object. Hit is never null. Hit.collider will be null if the raycast didn't hit anything. So if it's not null, then I'm going to say hit. Unity. Go, and I'm going to sort of rotate this around, but notice that it's, even though I'm sort of pointed at the barrel, it doesn't seem to hit anything. It's not printing anything. If I take the barrel and make it scene mode, take the barrel and I sort of move it over here, we get a bunch of hit. So a bunch of hit printed out. I moved it right above. You can see that this constantly is going up over here. If you squint closely, you see that I'm getting tons of these messages printing out, the hit messages. So it literally is pointed up. But it doesn't follow where our rotation is. So we are going to fix that. But first, let's draw the raycast so we can actually see it rather than having to sort of hope we know where it's pointed. This is what I usually do when I use Raycast, is I will usually draw the Raycast with a specific debug command so that I can see where it's actually pointing. Because it is really difficult to be like, well, I think it's pointing up, but it's not rotating with my object. So what do I need to do with that? It's just easier to just draw it so you can see exactly what it's doing. So let's see, we got the color here as red. This is what our ray color is going to look like when we actually draw it. So if we hit something, I'm going to change the ray color to be color.green. If we don't hit anything, so our if here is if we have a hit. If we don't hit anything, I'm going to have the ray color be color.red. So this is just setting up the color. The actual drawing of the ray is very easy to do. You say debug dot draw ray. This draw ray doesn't have anything to do specifically with a raycast. It's just a way to draw a ray, which is an origin, a direction, and a color. So the origin is this dot transform dot position. The direction is up, and the color is ray color. And that's actually all I need. This is why in our up vector, I did the 10 here, because this is going to draw at the correct length. So this isn't just direction. This is the direction, and it also includes the length. So for the raycast, this does not include the length. For the draw ray, this does include the length. So it's one of those little quirks, right? They don't make the call exactly the same. And then of course you have the color as well. So this will draw the ray as long as you have the gizmos on. So I'm going to save this, over to Unity, let it compile, and when we run, there's my ray. But notice, like I said, it doesn't rotate with the actual chest. In the scene view, if I move this barrel over, as soon as I intersect that collider, that's when we get the hit, and notice the color changes. When we move it away, now the color is back to red. So it interacts with that collider, and in this case, it's just doing some printing. You can also check certain things, like, for example, back in here, you can check things like if hit.collider.compare tag, for instance, so you can look at the tag. If it's the player, then it will do certain things. So maybe you're hitting other stuff, but the tag isn't the player on that other stuff. Then maybe you don't want it to react in a specific way. So you can still check all sorts of information about the collider itself that you're hitting. So that is something to keep in mind. I'm going to leave that off for now. In fact, I'm going to get rid of this print now as well, because we have our draw ray to show us what's actually happening and the color change. But how do we get this to rotate with the actual chest itself? I want to be able to move my mouse and have the ray always pointed at my mouse. That is going to happen up here. This is one of these function calls that usually you'd have to look up, that you're not always going to use in various situations, but it might be useful sort of now and then. So just like with other libraries you may have used in the past, if you haven't used JavaFX in a while, you'd probably have to look up, all right, wait, how do I import an image in again and then display it so I can like mess with it? That's what basically this is. So we're going to say transform, and we're going to put this stuff here in parentheses here in a second, but we're going to do transform. And we're going to do dot transform direction. So transform direction from local space to world space. Think about what that means. Local space. That's the local orientation of my object. In other words, when my object rotates, locally it has a rotation. We're going to turn that rotation, that local rotation, into a world space rotation, which means everything is going to rotate according to whatever my local is. Not the whole world, but everything associated with this object. So I can use transform direction. And I'm going to transform up. I can keep the multiplication here outside. I'm going to transform whatever is up in my local space. I'm going to transform that to world space. So watch what happens now. Compile. Now everything associated with this is rotating. So when it rotates, it'll rotate all of the other stuff associated with it as well. It's doing this transformation from a local rotation to sort of rotating in the world. And so what we can see is that as soon as I hit that collider, I get this green sort of debug ray drawing. And then as soon as I leave hitting the collider, I no longer have the green ray. Now, what this is useful for, I mentioned the sort of like Raycast thing to represent sort of an instant hit weapon, a hit scan style weapon. You can think of this too as things like enemy visibility. If an enemy is walking, doing some sort of patrol, and it looks around, so say it does some sort of rotate where it turns around and walks the other way, if it detects the player, it might need to change state. Maybe it changes from a patrol state to a chase state or to a shoot state or something. This can trigger that sort of state change, where you get a hit on the Raycast, the enemy has now seen you, or sort of seen you, and then it changes its behavior. Something that's probably not very common in most of your classes is that the professors usually probably don't do the final project, don't actually do the final project sort of with you, or do their own sort of final project version. But I did do that. It's probably not as it's not going to be as polished as I might want, but I did create a game with along the same theme. You can't save them all, and I'll put that up on GitHub so you can take a look at it. But I do use some raycasting in there. It's not super long raycasts; it's actually short raycasts, and it has to do with the player sort of blocks certain stuff, and so I want the object that's moving. If the player gets in front of it, the raycast detect if the player's in front of it and stop the object from moving. So that's sort of another use case. So you'll be able to see that use case if you're interested in it at all on Thursday when we have the final exam for the class, or the final presentations for the class. I will give you sort of a short demo of the program that I created. I don't know if it's 100%. If it's 100% appropriate, it's a little bit gory. So we'll see. There is blood spatter particle systems. So it's just little squares, so it shouldn't make anybody queasy, but you never know. So I do have Raycast in there, and I'll show you how that works. So you will see another use case of this. But if this seems useful to you, I recommend messing around with just this little sort of demo that I created here. See if you can get it to where there's something in between the Raycast. So there's another object in here that has a collider. See if you can get it so that it doesn't collide with that one, only with the one that you want it to collide with, for example. You can do that sort of thing with layer masks, for example. That's something that, in principle, we could talk about, but I think I'll leave it for you guys to mess around with. So see if you can do that sort of thing, because this Raycast can be super useful. Oftentimes in things like platformer games, to determine if you can double jump, there's just a tiny Raycast shooting out from the player to determine if you are on a wall and not on the floor. And if you're on a wall and not on the floor, then it will allow you to do a wall jump. Or if you're not on the wall and you're in the air, then you can do a double jump, for example. And so being able to determine the if on a wall or if not on the floor, Raycasts can help you with that, because you can record what Raycasts are hitting. And depending on what Raycasts are hitting, you can do certain actions. So there's lots of sort of interesting things you can do with Raycasts. And I wanted to show you a little bit of it today so that it's not sort of intimidating when you see this like physics.raycast and then all these arguments, that it's not something to be intimidated by. It's just go in, do it, draw the ray. I always recommend drawing the ray using the debug.drawRay, because it makes it so much easier to figure out what's going on and what Raycasts are hitting. And yeah, that's sort of your very basic intro to some of this Raycast stuff. So does anyone have any questions? You want me to go back to the code? So yeah, so the Raycast stuff just right here. Just picking a direction. doing the raycast, checking to see if that collider is not null to do something. Otherwise, change the color. In this case, just change the ray color, and then actually drawing that ray. If you want the ray to last longer, the fourth argument here is a duration. This is the seconds, so how long it will be visible for. If you leave it off, then it's essentially only visible for one frame. But if you put it in there, then what you're going to get is the raycast line is going to be drawn sort of continuously, and it'll stay there for a while. So we can sort of see here what this what angles this raycast can sort of see this hit. So it can be useful to have it display for longer, but I typically just leave this argument off. All right, so any questions before we go back over to the tile map stuff? In the game that I'll show you that I made with the sort of the final project game jam thing, I use a 3D raycast, so it's slightly different, but it's recognizable in terms of the arguments and stuff. All right, so I'm going to open up the other scene I have here, that starter scene. So this is sort of where we left off. We have this little circle here that can move around. We have the pixel perfect camera on here. I get a little bit of sort of like white flashy stuff here. That's just being in Unity and having the pixel perfect camera on. But the point is, we have that collider, so it's the composite collider, so I don't get some weird stuff where it's trying to go in between the tiles or something, and I can actually like move around and do hit the walls and the chest and all that kind of stuff. So we're going to talk about a couple of useful things today that are with this 2D sort of extras package. So placing those individual tiles, grabbing each individual tile, being like, all right, I want walls here, and I want these walls here, and now I got to put the corner tiles in, and I got to put maybe some random tiles in for the floor. So maybe you got like a floor with a tile that has a crack in it, and then a floor that maybe has a little bit of grass or something poking through. You know, whatever sort of random tiles you want to put in a room. And then the walls, and then maybe the placeables like tables or chairs or lights on the wall or whatever. It can get very tedious to do this, especially if you've got 100 tiles, 200 tiles to mess with. So there's this 2D extras package, and when I wrote this lecture, it was not in the package manager, and I still don't think it is. I don't know when they'll add it, probably with one of the updates for the 2020 branch or the 2021 branch. If you do need it, it's here. It's on GitHub. So it's that page that I showed close to the beginning. It's this one. You basically just download this, and it has you just sort of load it like a regular package. So it's still loaded like the package manager. You just have to do it manually. So it's not anything crazy. I've already done this for you. You already have this package installed if you're using the repo for the tile map lecture that I put up for you guys. So you already have it. Their notice, again, which was 8 days ago, was that they're changing how they do this, and they created a tile map extra package, which is available in the package manager. So moving forward, this repository is not going to be updated anymore, and you'll be able to just download it like any of the other packages that we've already done. What this package does, and what it will do in the future, when it's updated in the package manager and all that, is it gives you things like animated tiles. So you could have a tile that represents water, for example, like a waterfall background or something. And you'll be able to use several frames of animation to make it look like it's actually water falling down, rather than just being a static tile. So it includes stuff for that. A rule tile, which are really awesome. And then a few others as well, things like different types of brushes, like a game object brush, which we're going to talk about as well today, and then a few other things. The big ones we're going to talk about today are the rule tile and the game object brush, or what they've called it in the past, prefab brush. Rule tile is going to be first. There are some programs out there, and I've seen them on the Games from Scratch YouTube channel before, where they will actually create the rule tile for you. So you code you do something in this application to set up your tile map, and then it will go through and create the rule tile for Unity for you. So you can just drag the rule tile into Unity and you'll have it ready to go. Because setting up a rule tile, if you've got 100 plus tiles, is really a pain. Once you have it set up, though, it makes painting tiles very, very easy. So we're going to go over the rule tile first. Yeah, and then you can download the zip, and then you can add it into the package and all that kind of, add it into the Unity and all that. Okay, we're going to create a rule tile. We're going to right-click in our assets folder. I'm just going to put it in the same place as all my other tiles, and then we're going to say create 2D tiles rule tile. So I'm going to show you where that is. So I'm here in my assets folder. I'm going to go to my palettes here, and just where the rest of my tiles are, I'm going to right-click in here. I'm going to say create 2D tiles rule tile. So it creates it here. I can give it a name. Maybe I'll just call it rule. And I have the stuff here in the inspector. The default sprite is just like it sounds. When you paint with this tile, so I have all my other tiles here. When you paint with this tile, this is the default sprite it's going to use. So I'm just going to pick the floor tile. So here we have all of our tiles. I'm going to pick the floor tile here. And you can see down in the preview that this is essentially what my rule tile is going to do if I start painting in this, whatever this is, 16 tile region. So if I pick this rule tile and started painting on my tile map, this is what it's going to paint. Not very interesting yet. We need to select the default game object. This is your palette. So if I click on the little circle with the dot in it, I'm going to pick my palette. The dungeon one is the one from the finished product. So I'm going to pick my palette here. So that's the palette that this rule tile is going to use. For the default collider, sprite is fine. You could do something with grid if that was the way you're going to set stuff up. But since we're using colliders and composite colliders and stuff, leaving it as sprite is just fine. Then there's a list of tiling rules. If I create a new one, so I'm going to click on the plus here, the game object is my palette. Collider sprite, output single, that's perfectly fine. For the output, you could have an animation here as well. So you can combine animated tiles with rule tiles as well. So there are sort of options for that. Single is fine. You can also do random. So you can pick a random tile from, let's say you have a whole bunch of little placeables, and you don't want to specifically go in and say, I want a chest here and a barrel here and a broken chair here and whatever, and like a sconce or something on the wall. You could pick random and then have it, every time you place a tile, it puts a random tile of your choice of some list of tiles you give it. You picks a random tile and places it so that you don't have to go and pick out which tiles you want to specifically put. So there are some options here for the output. We're going to leave it as single. And I'm going to select one of my actual tiles from my palette. So these are all my tiles from the palette. I'm going to select one of them. The first one I'm going to do to hopefully help illustrate this is I'm going to select the north wall palette, or the north wall tile. It shows that particular tile. So notice how it filled up this region with every single one of that tile. It's not quite what we want. And setting this up properly can be very difficult, especially if you don't know what this sort of specific 3x3 square here is doing. So next to the image where you select the tile, there's this 3x3 region. Around the outside, the 8 tiles around the outside in this little 3x3 sort of grid thing represent either where you must have a tile or where you have no tiles. So for example, this should only ever be, if we look at our image here, there should only ever be a situation, this tile should be drawn when there is no tile above us, but there is a tile below us and a tile to the left and a tile to the right. If you look at every single one of these top walls, every single one of them has a tile below, to the left, and to the right, but no tile above. So I'm going to put that, so that sort of info into this 3x3 region. So if I click once on here, it's going to put a little arrow. That means there must be a tile below. So if there must be a tile to the left, I'm going to put an arrow to the left. I'm going to put an arrow to the right. There must be a tile to the left, right, and below. And there is no tile above. If I click, there must be a tile above, I get the arrow. If I click a second time, I get an X. X means no tile above. So the only time this tile will ever be drawn is if there is no tile above, but there is a tile to the left, down, and to the right. So you go through every one of your tiles and make these sorts of selections. So let me show you another one. I'm going to pick another tile. Let's pick the one with the wall. Let's see. Let's pick the one with the wall. Let's pick one of the cardinal directions. So let's pick the east wall. So this is the one that has the wall segment on the left side of the tile. So if we look over here, if there's a wall segment on the left side of the tile, then we need a tile to the left, up, and down, and none to the right. And so this is sort of drawing that out for you, showing the preview. It's not exactly correct. It's not always sort of correct, because you would think that there should be wall tiles all along the top. The preview does a pretty good job, but when we start painting with a tile, you'll sort of see that it does work. It does work properly. So I'm going to do this for a few more of the tiles. We're going to do the cardinal direction ones first. And if you want to see this sort of totally filled out, you can go to the finished folder, and in the palettes in there is a rule tile that is totally worked out. But I'm going to work out a few more of these. So let's say we want to do the south wall. Well, the south wall, there needs to be a tile above, to the left, and to the right, and none below. So you see we're starting to sort of build what kind of looks like a room here. Let's grab the west wall. We'll do the same sort of things. This one, there must be a tile to the right, up and down, and no tile to the left. So I got these. And then I need my corner tiles. So my tiles here, that's why I have the northeast and the northwest and the southeast and the southwest. So let's do those real quick. So this is a northeast. So northeast. This one has a tile. So that's this tile here. This one has a tile to its left and a tile below. It also needs a tile in this diagonal direction, because this is meant to be a corner tile. So I'm going to put an arrow in that diagonal direction. And then everywhere else, notice that everywhere else around this tile, there's nothing. And so now I get this tile in the appropriate place. So I'll make a few more of these and we'll fill them in. So northwest is basically just the opposite here. So it should be these ones here, and then X is out here. So we get the tile right there. And then we'll do the south ones as well. So the southeast, that would be this guy. So do these. And the very last one here, southwest, will be like this. This can be a pain to set up. If you've got 100 tiles that you got to mess with, and this isn't even going to do a very good job of doing painting for us, and you'll see why here in just a second. The point is, you can set these up, and then when you paint with this rule tile, it will look at the rules to determine which tile to actually display on the screen. That's going to be the power from this. So you can go and grab the one from Finished. So in Finished, under palettes and tiles, you'll see a room rule here. And I think they're in a different rule or a different order. But there is another one here that you can mess with if you want to. For now, I'm just going to use this one, this rule one that I just made. And I'm going to go and open up my palettes. So remember that is Window, 2D, Tile Palette. This is the My Palette, not the dungeon one from the finished version, but the My Palette. And I'm going to take this rule tile that I just created, I'm going to drag it in here. So this tile right now is my rule tile. It's displaying the default sprite, but it is actually my rule tile. And let me edit this and just move it actually. Over there. Okay, so that's my rule tile. If I paint with this, select the paintbrush, make sure I'm on this guy. If I paint with this, watch what happens. I'm going to put one here. That's doing the default tile. But watch what happens as I paint with it. Now you get some weirdness like this because I don't have a rule that deals with a tile here, here, and here, and here when I'm pasting one right here. There's no rule that does that, so it just puts a default tile. But as soon as I make a square out of my tiles, because of the rules that I set up, it will create a room. And all I'm doing is painting with one tile. I don't have to go select the floor and then paint it, and then select the top and paint it, and then select all these specific ones. It lets me do it just like that. It shows you a preview as well. Right? So it shows you a preview like this. That's what it's going to look like if you paint that tile. Again, I don't have one where if I paint a tile and it only has a tile here, here, and here, and then no tiles elsewhere. I don't have a tile. I don't have a rule with that, so it's not going to actually do the floor. So I don't have something where this will work properly. I don't have a rule where that works properly. So you do have to be careful. You need lots of tiles to account for every possible combination of that 9-tile setup. And as soon as you account for all possible 9-tile setups with your painted tiles, then you make a rule out of it and you can just paint. And you can paint whatever shapes you want, and all the tiles will align themselves correctly, and you'll get all of the appropriate tiles. So I don't know if anyone used Tilemap for the game jam, but if you did not use this, then it was probably very tedious to create complex tile maps. Whereas with this, it's not too bad as long as you have the appropriate amount of tiles. Again, we don't have very many tiles, so we can't account for all those other situations. But in principle, if you're drawing a tile map, a dungeon tile map, you're going to have lots of other tiles that you're going to use, throw them into the rule, and be done, and just paint, do sort of the art piece after you get all of this rule stuff set up. So hopefully that little demo was or will be helpful at some point in the future if you decide to do some sort of tile map based game. Does anyone have any questions on it? I do think it's a cool feature. A lot of game engines and a lot of programs do have this sort of rule feature, so I would expect this to become maybe easier to use in the future, especially because now it's actually going to be integrated into the package manager rather than being sort of a separate thing. But yeah, does anyone have any questions about this rule tile? Definitely the hardest part is just figuring out what these arrows need to be. And to me, the easiest way to do it, the easiest way that I've always looked at it is I draw out a room and then I go, okay, it's this tile that I'm working with. It has tiles next to it like this and no tiles around it like this. And so then that's how I draw out the stuff here. The other ones here, like the north wall, could be a little bit better. The north wall will always have angle tiles here as well. So potentially I could put these in here and it'll never have, at least the way this wall is written, it'll never have tiles there either. And if you change the rules, notice it changed it on the map as well. So if you've realized that, crap, I got one of these rules wrong, you don't have to do any repainting. You change the rules, it will change the tiles automatically in the map as well. I did use this a while back. Actually, when I was first writing this lecture, I used this a while back, and it just did not work properly. So I had to wait and come back later when there was an update, because it would create like infinite tile maps. Like as soon as I would try painting with a rule tile, it would start creating more and more tile maps for every tile I painted, and it would just get into this recursive loop. So some stuff I do want to warn you, some stuff, particularly if it's not already in the package manager, may not work properly. So I have had problems with the rule tile in the past, but sort of more recently, it seems to be working properly. I don't remember even actually which grid I was on. Might have been on the floor grid. Yeah, it looks like I was on the floor grid or something. For our demo here, it doesn't really matter. Okay, I just want to show you next. I have a few sort of slides here that sort of show you a few of these things. Here's the sort of example that we did, and sort of how this works. So you can always come back to this as well, the slides here, and take a look. Talk about the 3x3 grid. So you click on that and you put arrows. I haven't messed around with what happens when you press the center button. It changes to a couple different options, but I actually have never messed with them. I don't know what specifically they do. I think there's some stuff with like rotation and things that you can actually do in certain situations. So if you have a tile and like let's say your bottom wall tile and your side wall tiles are all the same tile, they're just rotated, then you can do stuff with rotations with this center thing. But I haven't messed with it too much, so and that may have changed since the last time I did it. And then you paint, and we get some sort of nice square rooms with the tiles that I provided. But of course, if you do something that doesn't exist in the rule set, then you're going to get some potentially funky looking things, mostly related to the default tile that you selected. All right, the other thing I want to talk about here is the prefab brush, and this sort of goes for any brush that you create. And what I mean by prefab brush is, let's say, for example, rather than that chest just being placeable that the player can't walk over, maybe that chest is supposed to be interactable. Maybe it's supposed to be a prefab itself that plays a particle system when you get close to it and press a button. It plays a particle system and an item pops out or something. Maybe it needs to have more interactivity. You don't want to have to go in, place a chest, move it in the exact correct location on the grid, and then have to do that for every single item that you put in. It'd be nice to just be able to paint your prefabs, like if you were doing a platformer, maybe you want to paint some coins in rather than having to drag individual coins in and move them exactly where you want them. If you just want to paint them on the grid, that's what a prefab brush like this is for. So it's under Create, 2D, Brushes, Prefab Brush. They may have changed that name, considering in the GitHub repo they called it a game object brush. They may have changed it, but it'll either be game object brush or prefab brush. So in my palettes here, and actually we'll just put it in my palettes place here. But you can put this somewhere else. You might have a folder called brushes or something. I'm going to right click in here. I'm going to say Create, 2D, Brushes, and here I have a prefab brush. We don't have any prefabs in this project to throw in there, but I'm just going to name this the chest brush. And you can see that you can throw a prefab in here. So I could take a prefab that I had, maybe I have a coin prefab or a chest prefab, whatever the prefab happens to be. I can drag it into here, so I can grab something here, throw in the actual prefab, the actual game object. And then in my 2D tile palette, I go down here to the brush. There's a little drop down for the brush. You don't drag this one in. You change the brush. The default brush will draw tiles. Down here, you should see whatever you named your brush, you should see it in here. So I also have this chest prefab. That's from the completed version of this. So the one I created here was chest brush. You can see it right here. Now, whenever I draw, it will draw that chest prefab. Whatever object is here, it will draw it in the grid. So that's how you change your brush, and you can add. There are other types of brushes and stuff that you can mess with and create. In here, there's some default ones. There is this game object brush as well, but there's like line brush, random brush, tint brush. So there's other brushes that you can use, but you can create your own. So that's just sort of one of the other features that this allows you to do, and it's useful for stuff like I want to paint a coin. I want to paint a coin in the exact correct location on the grid, and it's a prefab that has an animation and a sound effect and all that kind of stuff. You can do that. So that is something to consider when you're making any sort of map. And then remember, when you want to go back to painting tiles, you go to the default brush, and then you can paint the tiles. So I don't have any sort of prefabs to show here, but I'm sure you can figure out what to do when you're messing around with this prefab brush. So that's just another nice little nicety there. And I just show a couple things here. You can make a chest or make your barrel of prefab. Maybe the barrel explodes or something. When you blow it up, you can actually also you can assign multiple prefabs, and it'll pick one. It can pick one at random. So there's the random prefab brush as well. So maybe you have some barrels that don't explode and drop gold, and some barrels that explode, like in Diablo 2, that sort of thing. You can paint it, and it'll pick a random one. And in principle, even you don't know as you're painting it which one is which. The last little piece for today is about lighting. We've set all of our shaders to be unlit, but lighting is very important in games. Lighting is one of these things that's oftentimes overlooked, but it can really set the mood for your game, especially when you have extra sort of textures. My sprites right now only have the color texture. It's only the color map. But if I put in a normal map and maybe a specular map, so a couple of different types of images that represent certain things, I can get some really cool looks with just a simple sprite, a simple sort of tile map like this. If I were to do like a normal map or something, it could make light look like it's actually shining off of something 3D, even though it's only a 2D image. So if you want to look more into some of the different types of maps that you can use with textures, I do recommend doing that because it can be quite cool. So you'd want to look up like normal maps or normal map creators and stuff. So you want to get some extra lighting in here because this isn't very moody. If this was an actual dungeon, I mean it's a little bit boring, a little bit flat. One of the things you want to make sure to do, if you want to do sort of lighting in a sort of tile map like this or in sort of the 2D sense like this, is you want to make sure that the universal render pipeline, which typically this asset is created when you add all the universal render pipeline stuff in, or when you create a new URP project, you want to make sure you're using a 2D renderer. This is something that you can just create. So if we create, we should be able to create the rendering and universal render pipeline, and we can create the 2D renderer. So you can create this yourself. If you're using the forward renderer, that's a perfectly fine one to use. That's, for a 3D project, that's fine. But if you want to use some of the 2D features, then you're going to want to use the 2D render, and that is already in here. I already have one of these. Now, I'm not going to change any of the properties here because I'm using the 2D render, and in the URP, I already have that set to the render that's actually being used. If I go back to my grid, this is where we set the material for the actual tiles on the grid. So if I take this floor grid here, I have it set to a sprite unlit default. I'm going to set this back to the lit default. Same thing with the collision grid here. Just back to lit. Now, it's not working. Even though I have a light in my scene, I have this directional light, and I can increase the intensity and nothing happens. That's because you can think of this as the difference between 2D and 3D. The directional light here is going to affect all the 3D stuff in my scene. But it does not affect the 2D stuff that I have, the tile map. To create a light that affects the tile map, in my hierarchy, I'm going to right click. I'm going to say light 2D, global light 2D. With this global light 2D, now if I adjust the intensity, now we can actually start to see what the lighting's doing. And we can change the color and stuff, of course, too, right? We can have a red color, green color, whatever. We can adjust all the normal stuff you can do with your lighting. So maybe we want the dungeon to be a little bit darker, like this. And then maybe we want the chest to look like it's glowing. So it has like a light around it, like a shiny sort of halo of light around it. That's easy to do. I create another light. And you could add this light as like a child to an object or something. But I'm just going to create another light, 2D. I'm going to create a point light. And I'm going to increase the intensity. And I'm going to move it. And let me turn off the gizmos so you can see it a little better. And there we go. So now I have my point light where my chest is located. So if I had some lights on the screen, or so if I had some sconces or something on the walls or something, then you could do some cool stuff with the light here, because you can change things like the inner radius and the outer radius. So I can do something like this and have sort of the inner radius be a little bit brighter around it. In code, you can change this so that maybe the outer radius sort of randomly sort of flickers around, so it looks like there's some flickering going on. You can increase or decrease the fall off. So there's all sorts of properties you can mess with something like this. You can even change it so it's only doing stuff at certain angles. So maybe you don't want it to shine into or sort of beyond the wall stuff here. You can rotate this properly and do all that. So there's lots of stuff you can play with here. And again, if you had another map, like a normal map, then your normal map will interact with these lights. And you'll get something that looks like 3D lighting effects on just a 2D image, which will make the game look much better as well. You do the same thing for all of your different graphics, and that would just be messing around with the shader. The shader, you add the appropriate graphics, you add the appropriate color, the albedo setting, and you add the appropriate normal map, and you can get some pretty cool stuff out of it. So that's the idea with lighting. You want to use these 2D lights rather than the regular like directional light and regular point light and all of that. It's going to be global light, point light 2D, that sort of stuff, and that can really add a lot of mood to your game. Yeah, and there's various things for doing certain blending. You can have the light be you can have certain orders of the lights. So maybe you want a second global light that is much less intense. You can make sure that that's sort of which ones are being sort of rendered in which order and stuff to create different effects. So there's lots of cool stuff you can do with the lights. But that's the idea with lighting. I do recommend, if you're going to make a sort of a tile map that represents something like a dungeon or a forest or whatever, that you do mess around with some of the lighting stuff, because that can really make that can really set the mood and make the game look a lot better as you're sort of going through the process of sort of updating graphics or making sure the graphics look good. All right, so back here. So I mentioned a few things about the render pipeline stuff, and I sort of show what I made there. This is in the finished one, so you can always go take a look at the finished version as well. So that's basically all I want to talk about tile map wise. The few things in this lecture they're just sort of extra things that you can do. Unity's adding stuff all the time. So make sure that you come along later and you're like, wait, what's this? There's a different kind of light that's added, or now I can do something different with a tile. Great, go mess around with it. Open up a sample project and just start screwing around, because Unity adds stuff all the time, and they change things all the time. So does anyone have any questions about this sort of tile map stuff that we talked about over the last couple lectures? All right, so that's basically it. That's pretty much all I have for today. Unity has tons more. I mean, we only went over a fraction of the kind of stuff that Unity can do. They're always adding new features. Some features are paid. If you want to do like the industry AR VR stuff, that's the Unity Mars stuff. There's paid things, but the majority of it is free. And if you make less than $100,000 a year off your Unity stuff, you can always just continue using Unity Personal to do all your stuff. Now that they took dark mode or the sort of contrast mode from Unity Pro and brought it down to Personal, there's almost no reason for the upgrade unless you need their extra features. So they're always adding new things. There's obviously lots and lots of tutorials out there. If you like messing around with some of the art aspects of it, so you like messing around with the particle systems and the VFX graph and the shader graph, that's awesome. I like messing around with that stuff too. Watch some of the GDC videos that come out. Unity puts out a bunch of videos as well on all sorts of stuff. They have a bunch of training projects. So I know they sort of started it with like a racing game, but they've had a bunch of games already that have come out, and they just let you mess around with stuff. similar to just opening up a project that someone else made and just have sort of a small sort of tutorial description, and then just sort of let you go ham and just take a look at everything that they've done. The presentations for your Game Jam game are scheduled at the finals time. So our finals time is right here. So it is December 10th, 8 a.m. to 10 a.m. So it's definitely earlier than we've had our regular classes. So you want to make sure to be there for that. I know that if I'm not mistaken, there is a specific high-profile game that comes out, at least in the U.S., at least Eastern time, 7 p.m. or something tomorrow. So you don't try not to stay up too late, or if you do, then you may as well just stay up and continue to play that high-profile game, and then come give a presentation, and then go back to playing that high-profile game. I'm not saying that that's what I'm going to do, but I'll probably be watching some people play it on Twitch starting tomorrow morning, I think. So if you know what game I'm talking about, great. If not, that's it's hard to miss a release from CD Projekt Red these days. So so the presentations will be that time. We'll have all the groups give a presentation. Look to the order of, I think I mentioned this in the PDF. You look to the order about 15 minutes or so. I don't want people going super long. And just show a demo, talk about any of the interesting things that you might have done. For example, in the one that I'm going to show, I'm just going to talk very briefly about the raycasting that I did. That's sort of the main feature is these objects stop moving when they get too close to the player. So I'll talk about the raycasting, and then of course the blood spatter particle effects. So I'll talk about that just briefly. I'll just spend a couple minutes. I'm not going to do a sort of 15-minute presentation on it, but show a few slides, show a demo of your game, make sure that sort of everybody gets in there and at least talks about something. Talk about it's something special you did with your art. I used for the game that I'm going to show, I did just use some of the Kenny NL stuff. So I used some of the 3D assets from that. So whatever you used, you can sort of make a mention of that, or if you created your own, that's awesome too. You can certainly mention that too. That'll be coming up on Thursday again, 8 to 10, same place, same Zoom call, all that kind of stuff. And I can put the rubric up. I have a rubric for doing it. It's basically just mostly my CS2 style rubric. So I can put that up if you want to see that ahead of time. And the last thing I wanted to mention, I was going to wait until close to the end of the semester to mention this. Wentworth did have a game dev club in the past. I was the faculty advisor for that. When a bunch of the senior leadership graduated, I think it was summer 2018. I think most of them graduated. The sort of leadership of it, the club sort of fizzled out. So if anyone's interested in reforming the club, especially now that we have a game dev class that should be taught at least every spring and fall, you can let me know if you're interested in that. It opens access to some of the recruiting stuff. The financial situation is a little precarious, of course, in most universities, so I don't know how much money it'll open up access to, but there is opportunities for money. And me and at least one of the other faculty were talking about potentially doing some kind of game jam focused hackathon in the future. We have hackathons usually in the fall when everything's normal, which are just sort of open to anything. And so there's been some discussion about a game jam focused hackathon, which is something that the Game Dev Club would certainly be a part of if we were going to do that. So if anyone's interested in that, seeing sort of how to set that up, we can certainly talk about it. I would certainly be more than happy to be the faculty sort of faculty sponsor mentor on that if anyone's interested. So yeah, that's pretty much all I have. So I will see you guys on Thursday. I don't know if anyone has any sort of final questions specifically about the final presentation or anything before we all go. Yeah, Joey, do you have something?
No, I just want to say thanks, Professor.
Yep. Yeah, no problem. I will see you guys on Thursday bright and early, and we'll see what kind of games you guys made.
Have a good one.
Sir?
Yes.
Can I ask you a quick question about my project? I can't figure something out. So, let me share my screen if that's okay.
Yeah, I'm